Good afternoon, everyone. Hi. Thank you very much for the introduction. My name's Phil Nash. I'm a developer evangelist from a company called Twilio. I just wanted to say hi to anybody on the left-hand side. I know it's a long way over there, so how are you doing? Cool. And the right, I guess you're right over there? It's good, yeah. We're good in the middle as well. All right, cool. Has anybody heard of Twilio before? A couple people, because they might have come and spoken to me over there already. But if you don't know about Twilio, we're a communications API. So that means we allow you to communicate with your users via voice, video, and text messaging, using the tools, languages, and frameworks that you already know. If you want to find out more about that, find out about anything that we do, come find me over there. I have stickers, I have T-shirts, and I'd love to talk to you about that. But right now, I want to talk to you about what is effectively, I think, a sad story of front-end databases. Because we all carry with us in our pockets our powerful browsers, which we know we're building applications for. But I believe they are being left empty, and we can change that, and we can make that better. And so I think we have, or two of the problems we deal with in front-end development are probably performance is one. We need to make our applications work quickly. And it was excellent to see Wasim this morning talking about server rendering pages and things like that. But when we're building these kind of big single-page applications, which I think are hugely important, obviously, to this community, we sometimes do need to reach across the network and gather more data. We need to get other stuff out there. So performance for that, when we go across the network, is a big issue for our applications. And secondly, offline. Now, we have a talk later about progressive web apps, which I'm really excited to hear from Chiro Nunez. And I imagine it's going to mention service workers, which are a great thing to help us keep our applications working when we are offline. But I don't think offline is necessarily the biggest issue we talk about. I don't know if you've tried to use the Wi-Fi in here, but maybe it's poor connectivity is really a problem in which that, our applications are trying to access the network over and over again, and maybe it's slow, maybe it's there, maybe it's off. That's an issue. But what we really need out of our applications is resiliency. I think that's the feature we're after. If we have performance, we also want resiliency. An application that is going to work regardless of the network connections and regardless of the user's device. And so that adds up to me as user experience. I chose this picture because I thought my dog was having an excellent user experience when I tucked her in that night. But I think you can put user experience on any picture, and it makes sense, right? This is my dog. We're looking for user experience. We're looking for a better user experience. If things work fast, and if they work well all the time, regardless of network conditions, then users are going to be happy. So I think this leads us to that world of front-end databases, and the ones we're maybe not using the most of. And so we have some options. In this, we've always had options since browsers for decades now, because we can always store data in cookies, right? It's a good place. I mean, 4K at a time, and you have to pass them back and forth over every request. But you could do that. We probably are if you're logging in and things like that. There is, of course, local storage. Who's used local storage in their applications before? All right, quite a few people, right? And it's probably because it's got a really easy API. Like, you want to set some data? You just set some data, right? It's easy. And that's cool, but it has some problems. Local storage is a synchronous database, which is very unlike the rest of JavaScript, right? It's kind of weird that you have to wait for a blocking thing to happen. And if you've got a lot of work to do in that database, that's eventually going to cause some issue with your rendering and potentially cause jank in scrolling and things like that. So we don't want that. And plus, local storage will not work, because of this synchronous nature, will not work in things like web workers and the service worker. So it's not really a modern solution for this, if you ask me. There was WebSQL. Anybody tried WebSQL? Yeah, a couple. Sorry about that, because it's dead. Right? It's a shame. Like, having a relational database in the browser seems like a good idea, and the browsers went and implemented it. Although they all implemented it with SQLite on the back end, which to the W3C meant that there was only one implementation, and therefore it's not a standard, and so deprecated. Good. So no more WebSQL. So what have we got left? As we said at the start, it's IndexedDB. It's this, I think, is our modern database for front-end development, and it has to be. Has anybody had a go with IndexedDB before? Not very many people, okay, because it's horrible, right? Maybe. We'll see. I think IndexedDB has a bad reputation. I think it's been talked about as having a bad API, and it's been, that it's asynchronous sometimes works against it. But I want to change your mind on that today. I want to see that IndexedDB can be something useful for us and can solve those problems that I talked about at the start, can make things more performant and more resilient. So let's take a look into what IndexedDB is. It's an object store to start with. So unlike Web SQL, which was a relational database, much like our MySQL or Postgres, IndexedDB is an object store. It's a NoSQL database that stores objects against keys. A little like Mongo or something like that. This means we can't necessarily join tables and things like that, but we do get fast lookups on our keys, and we can also do indexes on those keys, on the values within our objects as well. And those objects can store most JavaScript objects. We can throw dates in there, we can throw other objects, arrays, all that kind of stuff. We don't have to push it in and out of a JSON serialization or something like that. IndexedDB is going to do that for us into the object store. It's also transactional, and this is where some of the weirdness around the API comes up. But there's an explanation for that. Every time you access to read or to write to the database, you need to do it within a transaction. And this, whilst it causes a bit of boilerplate code, which I'll show you in a bit, does mean that what we're really doing is just asking the browser to put stuff in the database, or asking the browser to get stuff out the database for us. And we could be doing this in multiple tabs at any one time. And because we want our data to remain safe and secure and not corrupted in any way, we need the browser to look after it for us. So each of these transactions just gets kind of queued up and then executed by the browser when it's required, when it has the time to, sorry. And so this leads to us also having this weird callback system in IndexedDB as well. So we have transactions and then callbacks. We'll see how that works, but if I tell you right now, apparently the IndexedDB API was designed very much like the XML HTTP request API, which, as we know, is an excellent and fun API. But when you think about these things, that we have these transactions to deal with, and that we wait for the browser to actually do the fetching and things for us, then these transactions will make sense, and the boilerplate makes sense. And it's asynchronous. I've said this before. We have these callbacks that we wait for the browser to finish what it's doing, to finish any other transactions before it's going to deal with our next transaction. And this allows us to use it in places like the service worker, which is hugely important for those progressive web apps that we're going to see later. And finally, just for security, it does go under the same origin policy, much like any other JavaScript. So you can't use this across HTTP to HTTPS or different subdomains. Just keep that in mind. Right, let's see a demo. I did not have much time, so sadly I won't live code this one, although we've seen some exciting live demonstrations this morning already that what worked, which is excellent. What I have basically is this is a chat application. I've called it Twilio emoji. Basically all you do is send emoji. And it uses Twilio's IP messaging, or programmable chat API, just to build up a chat between people. So anybody can actually join this right now. I won't give the URL out because it will crash my Mac while I'm trying to do stuff with it. But this is just a chat application that was very simply built using the programmable chat API. And I want to go and show you. This is kind of how it works. And so I was recording these videos last night on the hotel Wi-Fi, which is apparently the slowest Wi-Fi I've ever used, ever. It's amazing, really. Because you see, I don't know if you can see down at the bottom, there's a send button that's all grayed out. And that is because it's waiting for me to join the channel over the WebSocket connection. And there it is. It finally came in, and it's green. And now it's trying to load all the messages from that channel. And it took quite a long time. And in fact, this looks like it's a long time, but I edited this video down. So that's how painful the hotel Wi-Fi is. And there we go. It came in, and then I get some weird scrolling behavior as well. But that's how it's supposed to work. And we can send a beer emoji as an introduction. I do enjoy making and sending beer. And so let's make this better, right? This is about performance and resiliency. I'm on a terrible network connection in this hotel, and I want to make it better. We want to use IndexedDB to make this better. And so what I'm going to do is store our messages that already exist in the channel inside the database, and then on the page load, we're going to get them out of the database straight away and put them on there so that we can see the messages already. So I'm just going to start the code there. I hope you can read that. But we're going to start by creating the database, right? And everything goes via request. This is our transaction kind of model. And using the IndexedDB object, we try and open a message store. We give that a version 1. And then that request has callbacks, 3 in this case, an on-error callback, which will get called if something breaks, of course. We also get the, and we're just going to log that. We also get the on-upgrade needed callback when we try and open a database. And this is called when we have a new version of the database. And so the version is in this number 1 up here. And this is where we add object stores and we add indexes and things like that. Now, we get the database out of the event object from event.target.result. And that is the case for most of these callbacks. Event.target.result will have the thing that we wanted. And what we do with the database in this case is create an object store. We're going to create a messages one, and I'm just going to pause that just there. Let's roll that back slightly. Just pause that right there to say I've used a key path here, a key path of SID. And that's because the messages that come through from this API all have identifiers under the key SID. Now, you can, at this point, use any other key that you want on an object, or you can auto-generate them as well, and auto-increment them like any normal database. So that can be quite useful. I just happen to have a key already. And then finally, when that's all done and we've gone through the upgrade, we get the success callback. At this point, I'm setting the database object back to its that DB that I've kind of made available earlier. And then we'll do some other stuff later. Because next up, we need to write the code to go and add messages to the database. So as you can see, my chat, when I receive a message, I'm going to add it to the message list and render. But in the middle, I want to create that transaction. And to get a transaction, we get it off the database object, and we tell the database which stores we want to work with. In this case, the messages store, and we want to read-write transaction. Then we get hold of that object store, the messages. This is the boilerplate that we see. And then we make that request. And we make the request to add the message to the object store. Although actually more usefully in this case, because we already have an ID, and we're going to do this multiple times, we can put the message in the object store, and that will either add it or create it. Either add it or update it. And then we can have a success function, which will log out yay in this particular case. And here is that application again, loading. And again, in this particular case, it's still, we've not loaded anything out of the database yet, but we put in the messages in. And as you can see in the dev tools on the left-hand side, on the right-hand side, we have IndexedDB, which is right here. And we're going to look into that and show just that after you refresh the IndexedDB, because the dev tools can't do that apparently, we have all our objects stored in that database. And there's the beer that I sent. Fantastic. And so we've stored our objects, and now we need to get them out. So we're going to go back to that success function where we created the database in the first place. And we're going to make a new transaction. And you see the pattern coming up here, and maybe this is why people aren't such a fan of it. We're going to use the messages store. We're going to read only this time. And we could leave that off. Read only would be the default. We're going to get our object store, the message store. And then we need to open a cursor on this. Now, rather than just like loading everything into an array of messages, what we get is a cursor, which allows us to move through the messages as they're produced from the database. And so we're going to open cursor. And that, again, has its success function. And the success function then returns an event which has a target and a result. That is the cursor, which we'll set here. We'll set the cursor. And so we're going to run through the cursor doing stuff to it. And whilst we still have access to the cursor, which means there's more objects to come, if cursor, then we're going to add our cursor.value, which is the message that's stored in the database, into our messages list, which is just how I've built this application. Cursor.value. And then we go cursor.continue, which will tell the database to go get the next one, and we'll receive the onSuccess function again. If we don't have a cursor, then we're done. We've got everything out of the database that we wanted, and all we need to do is do our rendering. And this time, we do our rendering. Cool. And this time, if we go back to the browser and check out our application, we can reload the app, and bang, the messages are there straight away. Now, you can still see that the actual connection hasn't loaded. Our send button is still grayed out, and we're waiting for that. But right now, our messages have loaded, and the user thinks that this interaction has been much, much, much better, particularly over that terrible hotel Wi-Fi. Cool. There's more to this API. I just wanted to use that as a demonstration to see what we could achieve with this in a very short space of time in not that many lines of code, and in just plain IndexedDB, and pretty much plain JavaScript as well. But there is more. As I said, there are indexes which you can create on the database. So rather than just having to use the key, you can create other keys which will order things. So in this case, if I wanted to order the messages on the dates, I would add the index date updated, which happens to be the key on this message. And that would give me an index on the object store, which I could then run a cursor over or pick keys out of. So I could pick by a date or run via ascending or descending order. There are upgrades as well. So we saw that on upgrade needed callback. When you change that version to another higher version, this was what we had before, but when you change up to a higher version, you need to do some more work. We need to make sure that people visiting the page for the first time get all the database tables, all the object stores, and we need to make sure that anybody who's visited before just gets upgraded to the latest version. So we just have a look at event.old version and keep running through those things. And we can make other object stores, add other indexes, add indexes to existing stores. There are some bugs to be aware of. This is when it's important to realize that it's not perfect, of course, mainly due to Safari. Thankfully, it's mostly fixed in the latest Safari, but Safari 9 and 8 are absolute horrors. If you have two object stores in the same database, and one key in one database matches a key in another one, the older one gets wiped out, just gone. It's awful. It's a horrifying thing, and some of the libraries that build upon IndexedDB just drop it for Web SQL in terms of in Safari support. The other one is that in Safari 9 and 8, you can't use IndexedDB inside of a web worker, so if that's of an importance to you, that's also a problem. However, it is fixed, I said, in Safari 10. It's a much better browser. There are libraries, of course, because we saw boilerplate, and that means that we can extract that away. And there are a bunch right here. If you like local storage, then you'll love IDB keyval or local forage, which are key value stores based on top of IndexedDB that work asynchronously, and then will work in service workers or web workers, except Safari. And then IDB is a promise-based thing, which actually it mainly follows the same API, but instead of on success and on error callbacks, you just get promises. And then Dexy and PouchDB are more thicker, kind of bigger abstractions. PouchDB effectively re-implements the CouchDB interface and also syncs with remote CouchDB instances as well, so it's really useful for that. But you're probably wondering about Angular as well, and if you're looking to use this in Angular, particularly a promisified version without the horrible callbacks, then you want to look up Angular 2 IndexedDB, written by Gil Fink. It actually works really nicely. It's written in TypeScript, so it has all those bindings. It's injectable, so it's just ready to go in your Angular 2 applications. And rather than seeing weird events, we do have in this case, we create store and we get a callback to make the store happen. If you want to update things, this is kind of our put that I used earlier. Then you just call an update and you get a callback if it works, or you get a promise which resolves if it works. And finally, you can do the same with cursors as well. It works basically the same, but it's a nicer interface and ready for your Angular 2 application. Now, I have 5 seconds left, so I can tell you there's an Angular 1 thing called IndexedDB as well, Angular IndexedDB, but that one's running out of support because people have moved on from the project, so just go to Angular 2, I guess. So that's what I want to say about the empty database in every pocket. We have this ability to build powerful single-page applications that can work really well, and IndexedDB can just enhance that experience. We get performance out of it if we can just make things load faster for our users, and resiliency because that stuff is stored off in the browser and can be accessed when offline as well. And so let's fill up those databases. Thank you very much for having me this afternoon. My name's Phil Nash. I'm a developer evangelist for Twilio. Come say hi over at the stand. Thank you.